So, just gonna let a couple of more minutes pass by so some more people can come in. Um, Today's workshop is going to be on the automated design of agentic systems, which basically means like how can we fully automate the process of designing agents, which is a very difficult problem because right now humans are currently spending too much time on building the prompts, building the configurations. This stuff takes a lot of work, and it's very um, not only does it take a lot of work, but also it consumes a lot of knowledge. You need a lot of knowledge to be able to understand what the what the premise of a task is. Like, how do you know? How do you teach someone an agent in something that you don't know about yourself? That's very hard. And so we're going to be leveraging today agents that can essentially create other agents better than you can, because they know more about us in most domains. We're essentially going to be using an agent to build multiple agents, who is going to be like the director. And then we're going to take the output of the director, which is going to make a plan. And then from that, we're going to make a JSON of the agents to be made using structured outputs. And so once these structured outputs are ready, then we're going to create agents, and then we're going to add those agents to the archive. And then now we're able to use those agents for what we wish, basically. And before I get into the code and running anything, if you have any examples or use cases you'd like to see, just type it in the box and let me know so we can help you solve that problem. I definitely I want to show you the spreadsheet swarm, which I think is it's undoubtedly one of my favorite swarms now. Um, it's just so easy to use. It's insane. And it might be the simplest swarm to oversee the outputs of many, many different agents all at once. Because previously, analyzing the output of multiple agents is very, very difficult and very time consuming. But with the spreadsheet, it's very simple. It's, you basically just keep scrolling and then you see all the agents there. So, I'm going to be presenting that in a couple of minutes. If you have any ideas for examples or demos, please let me know so we can, work on that. But yeah, this is we're doing this because there was a paper that came out a couple of days ago, less than 5 days, 4 days, where it's called "The Automated Design of Agentic Systems." And the paper is good. It's not really that good. They say they're the first, but Swarms has been doing this for almost 2.5 years now. And the thing is, though, the agents are defined by code, where you don't really need to do that. And especially agents are not like the code generation is almost always prone to hallucination. So we're just going to we're going to get the same outcome, which is a list of agents, but it's going to be much better than this because they're having agents just generate code instead of having agents that just generate the prompts and then we automatically build the agents with the JSON. So the way these people do it is just really dumb, to be quite honest. And honestly, I think, though, if we can get this down really well, the entire world economy as we know it will change. Because now we have people who have never learned anything about being a doctor or being a marketer can now become doctors or marketers and probably even surpass them because they have agents. And so this is very, very important. because this essentially breaks down the knowledge barrier in most tasks. Anytime you do things now, there's a massive knowledge barrier. Like if we look up what is the average time to finish med school, it's like 4 years. But to become a doctor, 3 to 7. Sometimes it can even be 10. Um, and we could even say, how long does it take masters in marketing? 2 years. Um, and that's the minimum. So what if we could just bypass all this time? 4 years, 3 to 7 years, 10 years. That's way too much time. That is way too much time now. And so the good thing about these agents and the benefit they provide to us is that they allow us to overcome those knowledge barriers that would normally take us many, many years to overcome. And so just by being good at prompting, at having an agent build an agent, all you have to do at this point is teach an agent how to build an agent, which is basically it's a couple of things. First, how do you get an agent to build an agent? First, you need to have a problem. First, you need to start off with a business problem or any problem, really. What is the problem here? I want to market my social media posts. Okay. So then after that, the boss is going to create a plan, which we specify here. And then this plan is now going to be activated. And the boss is going to output the agents it's going to make. And using those JSON outputs, then we're going to build the agents and then we're going to use them. And that way we don't need to be an expert in, we don't need to be an expert in like medicine or being an expert in marketing. We can just have agents, build agents that are good at those things. And the reason for that is like OpenAI was trained on trillions of tokens. We were not trained on trillions of tokens. Well, actually, maybe we have been, but the memory recall rate is significantly slower than if we were to just use an agent. We might have never been trained on medical data before. We might have not have read every single medical textbook. And so the value proposition here is that by having agents build agents, just getting things done is much faster and much easier. That's the premise. So yeah, let's get into it. I'm going to be in the Swarms, working in the Swarms repo today. Got a big update coming pretty soon. Agent creator. Yeah, so we have a pretty big update coming soon where just accelerate everything. It's agent execution has historically been very slow, but in the next Swarms update, it'll be hopefully 3 to 5 times faster, which is very fun. So that's very nice. And I'm just gonna import some things to get started. So first, we need to create a Pydantic schema. So we need to first create the base model for the agents, and I'm going to make this much bigger so you can see. We're going to first give it the name. What is the name of the agents? And for those of you who don't know, Pydantic essentially just makes it very easy for you to validate types and stuff. So here we're going to have a description, and we're going to have a field. Uh, and then we're going to have the system prompt, which is the most important thing. The system prompt is definitively probably the second most important thing in an agent. The first most, or actually, it might be the most important thing in an agent. The second most important thing is the type of LLM that you're using. A step by step, a custom system prompt for the agent that is very direct and provides instructions and multiple examples on how to complete its task. So with just these three parameters, we can already get started. We don't really, if we wanted to be a little bit more, if we wanted to be a little bit more precise, we could also have the boss essentially define the number of loops. But that may or may not be necessary for this demonstration. Okay, so now we have the swarm level. So here, I'm going to say swarm name. We're going to give that a field. And we're going to say name of the swarm. And then we're also going to give it, so what is the goal? Oh, I made a mistake there. I just got this new keyboard and still learning it. It's really, really good, by the way. It's called a Keychron. And yeah. So essentially what we're doing here is we're going to build the schema. And then after we build the schema, I'm going to show you how we can automate the design of agents, which is very, very powerful. And then I'll take any, demonstration requests. But first, we got to make a general system. So we have swarm name, we have the goal, and then we have a list of agents to make. Here, we also have to define the plan. So create a plan for the swarm, define the goal, and then create a list of agents that are needed to accomplish so and that's a pretty decent schema for now. We can also specify rules that may or may not be needed here. So to use this, we just define the model, which is this model, and then we're going to fetch schema, or we're going to fetch our key. And then we also pass in the, what is it? Base model, yep. Then here we pass in the schema, Okay. And then here we just import that. Fix that. Okay. Temperature. Let's see. Max tokens. That's pretty good. We're missing the most important thing, which is the system prompts. Now, I'm going to fetch this from the Swarm's Marketplace because there's a really good one over there. And then we are going to try running this and see how it goes. So here's a good prompt that I made previously. And we're going to define the prompt here. All there. Okay. So I'm going to delete this for now. Let's see. Okay. That should be good. So this prompt here basically says you're a director boss agent. Your primary responsibility is to manage a swarm of worker agents to efficiently, effectively, and skillfully serve the user. You must decide whether to create agents. Let's make that. You must decide whether to create a new agent with specific capabilities or delegate tasks to existing agents, ensuring that all operations are performed with maximum efficiency. So then now, we're going to run this. So now we need a task. So we could do something like this to start off with, and then I'll show you the output. So the output is going to be a dictionary, and I just want you to see this first before we go. And so this is the part where, okay, we got an error. Let's see if that works. Huh. So there's another error. Let's see. Max loops is not, default is not permitted. So this is the issue. We just block that off and then run it again. So now it's going to be working. Hopefully, it's going to output a dictionary of the agents to make, and then from there, we can get to work. There you go. So another thing we can do is we can make this pretty, and we can also save it to a file so we don't lose it, because that is not nice. Okay, so this is what it looks like. Let's take a look at this. Actually, we should probably save this somewhere. Let's see. Okay, so to provide comprehensive financial advice so this is the plan. We have to have it essentially contemplate the plan. Notice that we will create a swarm of specialized agents. Each agent will focus on a different aspect of financial advice to ensure thoroughness and expert guidance. Goal: provide financial advice on investing stocks and plans. And agent name: stock investment agent. This agent provides detailed advice and analysis on investing in stocks, including market trends, stock evaluations, and portfolio management. System prompt: you're an expert in stock investments. Your role is to provide detailed advice on stock market trends, evaluate individual stocks, and offer portfolio management tips. Use financial analysis tools and market data to support your recommendations. Um, and then it gives the examples. And then here we have another agent, bond investment agent. So this agent here, an agent that specializes in providing advice on investing bonds, including interest rate trends, bond ratings, and risk assessment. Now the output is a little bit small. What we can do for that is we have to eliminate fields here because some of these fields are going to be taking up a lot of space. So we can try and make the prompts better by just cutting out some of those. And then we're also going to create files for each of the names. So we're going to do something like this. Okay, start writing it. Let's see. So we could also specify the max tokens. Oh, this new keyboard is a little bit tricky. We could try 5,000. Yeah. So here's the new dictionary, and let's see if it created. Yep, it did. Created the dictionary. Here we only have 3 agents. Um, so here we have 3 agents. Now there's a couple of things we could do to make this even more extensive. By essentially having it build more agents, like we could verbally say, build more agents. Let's see, create a minimum that are hyper specialized. So the trick with LLMs is being very specific. That's the trick. So we're gonna run this again, and let's see if we, get multiple agents as we wish. We said at least 10. Yeah, so look at that. That's much bigger. If we tell the agent that we need, multiple, if we need 10 agents and need 50 agents, it should be able to, build those agents. So here we says rules. Each agent must focus on their area of expertise, provide advice based on the latest data and trends. Agents should collaborate to provide holistic financial advice, ensuring all aspects of investing are covered. Regularly update clients with new insights and changes in market conditions. Maintain transparency with clients regarding risks and potential returns. Um, Another thing about building agents is that you constantly have to be thinking about the future. Um, so here, I just realized that instead of having the rules be the last thing that gets generated, which is kind of dumb, it should probably be One of the first things that gets generated because the rules of a mission will often affect the plan to accomplish that mission. And so with that, the rules will now be defined, preliminary. And now that those rules will affect how the agent plans. And it's kind of like a game of meta optimization. You have to essentially be on the lookout for potential things to automate really well. And so now that we have all these agents, I'm going to show you how to actually build them autonomously. So we're going to create a function. So we're going to create a function that takes in the agent name and the system prompt. And then this will return an agent that we initialize with the following parameters. Let's see. So first, we need to import the agent class. From swarms, import agents. And then we can just essentially copy and paste this. And so this is an agent. Do return, and then we switch the name. So we also have to get another LLM for the workers to use. So we're going to be using GPT-4o Mini, this model's cousin, and then we're going to initialize that inside of there too to not waste any memory consumption, and then so we'll also do this. We're going to initialize this LLM. We're only going to have one loop. We're going to autosave, and I'm going to say that to JSON. So this context window, I forgot what it was. I'm just going to go to 128,000, and yeah, so that's pretty much it. So now we need to parse. Now we need to parse the boss, and this is going to return a dictionary that we need to parse. So we can turn this into a function. It says create. So we're going to give that a task, and then just going to put that there. And then this, we're just going to comment that out for now. Type in task. Then we can use this later. This is going to return an out. Or this is going to return the agents. And then now we can run this. Actually, I'm just going to make sure this all happens in the function. Perfect. Okay, so now things are slightly coming together. Now we need to parse, and then after we parse, and then we can actually start using the agents. So we just, to recap, basically imported some things, which we can shorten. Yep. You can format your imports really nicely using rough. So you just do Command Shift P and then format imports, and it will make your imports nice. Imports consume a lot of energy, so if you do imports wrong, you will be wasting a lot of compute. So I heavily advise against that. So we made a schema. This is the JSON that the agent is going to output. We have a prompt that we're using, and then we're initializing the model, which is basically going to create a list of agents, and then we're going to save it to a file just in case, and then we're going to create the agents. So now we need to parse agents from Dite. So we're going to say input and this should output agents. So we can also get the name of the swarm. And then what else? So we have the goal or the rules. Then we have the goal. So agents is really the biggest thing about agents is structured outputs and parsing. Those two things are the most important things that are really important. So we have the name, we have rules, and we have the plan. So this is the plan. We need to get the plan. Or actually, what can we do here? Actually, we can just leave that for now. We're going to make another function to log this. Log name, log swarm data. So then here we're going to log, oops. We're going to log all of this. So it's going to take in a dictionary, and then we're going to log everything here. Swarm name. What else? Rules, and then the plan. For the logger, we're going to use Loguru, which is really good. It's a really good Python logger. And yeah, that's pretty much it. Now we're going to run, or actually we're going to import a agent registry to save our agents. So this is a structure that we made just to help you save agents. So now everything is coming together, and now we just need to kind of merge everything. Oh, stupid screenshot there. Okay. So pretty soon, we'll be able to actually have agents run. So let's combine all of this. What was the name of the paper? Let's see. Design a run swarm. First, we need to run the boss agents. So now we're going to create the agents. And then we're going to log the swarm data. Then we're going to parse the agents. Let's see. Actually, here we're going to initialize the registry. So here we're going to then add this agent to the registry. So we're going to add the agents. See the method first. Yeah, just add. So we're going to add the agents. And then, so here we're adding the agent to the registry. And then, so here we say create agents. Agent sticks. And then we return oh, yeah, that's kind of dumb. This isn't public. This should probably be public. So we can fetch it, because fetching variables inside Python is not very easy. Okay. So we initialize that outside. Now we can return all the agents from the registry, which we do by actually we might have to make a new method for that. So we're going to say this returns a list of agents. And for Jamal. And yeah, that's basically the whole paper. Now we need to use those papers. So what we can do is we can let's see, switch our way on. So this is the prompt to use. You're an expert machine learning researcher testing different agentic systems. Brief description, framework code, output instructions. Discovered agent archive. Initialized with baselines and updated at every iteration. So the boss is going to have a memory of all the agents. So first, I just want to try this out very quickly. Okay, so if we wanted to get the boss to automatically send a task, this is what we can do. Be very specific. Make it very specific and clear. So now we need to parse this. Then we're going to run this agent on the task. So now we also need to fetch this. And then pass that into here. Okay, so let's try running this. I'm going to break up this prompt to make it simple. So create a variable time agents. Then here we're going to say, I want to know the rules of investing into stocks with my Roth IRA and how to get a tax break. So then we're going to run it and let's see what happens. Okay, we got our first issue here. Let's see what the problem is. Hmm. What's the issue? What's the issue? Hmm. I wonder where the error is coming from. Let's see. Okay, setting error. the problem. It's the registry. So let's remove that for now and just have an agent pool. So we're going to, where's the agents being created? Add to agent pool. So we're going to add this to the agent pool. And then boom. Now let's try running this and see what happens. All right, let's see. Delete that. Delete this. And would you look at that? We have now just fully automated the designs of a bunch of agents. Now I want to see which one is this? Oh yeah, so this is the one. Isn't this crazy? Like we could just build like extremely general systems that do all the work for us. So now this is the output of the boss that made the agents, made 10 agents. We have a Roth IRA specialist agent, we have a tax strategy agent, we have a bond specialist agent, risk assessment agent. I mean, we have all types of agents. And we just ran all of them. So this is JSON. We could also run this again.
I wanted to see what it was recommending at the end. You had a lot of people or agents involved. I wanted to see what its recommendations were.
What was that?
I wanted to see what the recommendations were when it generated the agents. Didn't it provide a solution?
Yeah, so this is the task that went to an agent. Yeah, so I gotta put more logging there to, I gotta make more logging so we can see the agents being created. But here's the answer from one of the agents. So this agent says that investing in stocks through a Roth IRA can be a strategic way to build wealth for retirement while enjoying certain tax advantages. Here's a detailed guide on the rules. So the rules. So to contribute to a Roth IRA, your modified adjusted gross income must be below certain thresholds. The contribution limit to phase out is at 138,000 for single filers and 218,000 for married couples. And there are contribution limits. So for 2023, the maximum
my question is the results here, right? The eligibility requirements, the count setup, and so forth. Is that produced by one agent, or does each of those agents contribute something to this process? Where did the coordination take place?
So the agents we're just creating the agents now, and then we have, so if you see the JSON,
right.
Each of these tasks is going to be sent to this agent. What we can do is to essentially have the director build the swarm, we're going to have the director output. We're going to have the agent, the boss create a swarm. And I'll show you how to do that now. But basically, the way that it's running now is that every agent here has a task associated with it, and it must complete that task. So the tax strategy agent is gonna do provide advice on how to get a tax break when investing in stocks. And so that's what you just witnessed. This is the result of an agent whose purpose is to Essentially, so this is the Roth array specializations.
Okay. Got it.
So, step
So
by
it's
step.
it's it's selecting one agent. It's not coordinating the agents yet.
It's no, it's actually it's sending different tasks to every agent. So every agent is going to have its own task. So this agent has its own task. This agent has its own
Right.
task. This agent has its own
Uh-huh.
task. Like each agent has their own
Understood.
task. We could change
Right.
that so that every agent will work together on one task, not multiple tasks. And I'll show you how to do that in a bit. Um, but for now, I just want you to see like this is essentially like this is how we build like fully automated agentic systems.
Yeah, it's very cool. Very cool.
Thanks. Yeah. So after that, we can we like I start showing you how the boss can create a swarm. So the boss is not going to just be outputting the agents anymore. It's going to be outputting a swarm of those agents, and then those agents are going to work within that swarm. So for that, we're going to use from swarms. We're going to import the agent rearrange, which is one of my favorite swarms. So this is a swarm where you can define the flow of communication just by putting an arrow sign. So we say agent this talks with agent that, agent this talks with him, and like I'll show you now. You'll get the flow. So then we're going to create a new field here. And we're going to say, we're going to give this as the description. Uh, so this is how the agent rearrange swarm works. Well, first you give it a list of agents, and then you define the name, and then an arrow sign. Or you could actually even make it parallel. So you can make it parallel by putting in a comma sign. So if you put a comma sign and you put another name, then these two agents will run in parallel. So agent one is going to do something and send its output to agent two. Agent two is going to send the combined outputs and send it to 3, 4, and then whatever they like. We could keep it going from here. We say use the arrow sign for sequential processing and or a comma for parallel processing. Follow this example. Okay, so that's going to be the flow, and we can parse that here. Okay, so now we need to build a swarm. Okay, so now we're going to make a new function, build, and run swarm. Actually, we don't even need that. We can use this. Okay, so this is going to take in a list of agents, right? And then it's going to take in a flow, and then a task. And then the output should be a string. So we're going to say return rearrange. And that's that. Okay. Now we need to glue things together. So here, Going to, what are we going to do? What are we going to do? We're going to create agents. Actually, I'll put that first. Whoa, 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 whoa. Okay. So we're going to launch the flow. We also need to log that. So we also need to get the right. Just 1 second here. Okay. So now we can also we can remove this because we're not going to give a task to the agents anymore, and we're not going to run the agents anymore. We're just going to this is some next level like stuff right here that I'm doing in real time. What was the function? Yeah, so build and run swarm. Okay. So here, now we're going to give this the agent pool, right? Then we're going to give it the flow, and then the task. And now, pray to God, this works. I just hope it works. Okay, so creating agents, right? Yep. So what's going to happen is we're going to create agents. We're going to log, the agent stuff. This is some of the log, and oh yeah. So we cannot. We got an error. Create agents. There's no more task anymore because the agents are going to work together, and we're not going to give tasks to all the agents. So each agent is going to receive one task, and then they have to work together. Shit. Tax advisor agent is now registered. Yeah, so the communication flow is the problem now.
So one of the challenges is it's hard. I don't know if you can anticipate communication flow before the team. In other words, if they can
What was that?
decide, you can't determine what the communication flow is before knowing what the problem in the team is, right? Usually, teams self-organize to solve the problem.
Well, ideally you shouldn't even be able to do that. The boss should do that, which is what we're trying to get
Right,
here.
and that's what I'm getting at is I think doing the rearrange is great, but in this case, I don't predetermining that. I don't know if that's going to be a good solution, and if it if it's doable, and if it is, it may not be a good solution. I
Yeah.
think what you have to do is an iterative process where they participate and provide input.
Well, let's
Static
see.
org
So,
chart or a sequence model. Those are some of my
Say again,
questions before the session started.
a
It
sequence
sounds like
model.
you're describing an org chart or like a sequence model, like which participants in a overall flow would communicate with each other. And you know,
I think that's one of the things that he put in there in the rearrange model is kind of this is the way we do things process. And what, correct me if I'm wrong, Kai, is one of the agents that was involved wasn't instantiated before it was called.
yeah, that seems to be the problem. So this is the flow. So it's kind of like Mermaid, but it kind of looks like Mermaid. So this is the agent rearrange. The agent rearrange is you give it a list of agents, and then through their name, you can get them to talk with each other. So you can say, I want the Roth IRA investment agent to talk with the tax break specialist agent who's going to talk to the stock market analysis agent. And so the arrows define the flow of information between each agent. And then if there's a comma sign, that means whoever is before that is going to be sending the output to two agents, or however many agents have a comma sign. And that's what you're
Mm-hmm.
seeing here. But now we have a problem where the agent it's trying to send agents that are not registered to the swarm. So what we can do about that is a couple of things. Humans ideally should not be setting this flow because we don't want to have.
Right.
We just want our problems to be solved. We don't give a shit about configuring agents or doing any of that stuff. That
Right.
to most humans, that's a waste of time. Humans just want to solve their problem. So we shouldn't be doing this. We can try, giving like being prompt, like what. So the flow is not going to, if this is in the output, it's not going to be receiving this. So we need to see. Okay, yeah. So that's not a part. Okay, good. That's
Yeah,
not a
I don't
part.
know if communication flow is a good solution for this problem right now, right? I mean, it's a cool tool, but I don't know if it's good use of it right here, is it?
It
Can we,
is.
can we, okay,
We just have to be very precise and say.
okay.
The thing is, though, I think it's hallucinating. So it's hallucinating agents that are not there. So um, this is what I'm going to do. I'm going to make this simpler so we can see the full instructions that we're giving. And then we're going to optimize this. If we can get this to work really quickly, the whole entire system will be fully autonomous. There will be no need for you to do anything except describe your problem. So now we could say, ensure that the names of the agents you pass are the same ones as you just created. Shit. Um, if you say, if you have not created, do not include them in the flow. Okay, so now let's see if this will work. Let's see. So basically, this is an implementation of this graph right here. And a much better and much simpler version of this paper. Yeah, you see, we keep getting that same problem. But we can double check. Um, so, so the agent is being created. It is there. So the problem might be parsing. It might be a parsing error. So you say only include maybe 3 agents in the flow at a maximum. Now let's try running this again. So this is a fully automated swarm design. Okay, you don't touch any prompts, and we got the same problem. Okay, it's not listening. So economic trends. Okay, communication flow, our rough array. That's yeah, that's more than 3 agents. Maybe if we make this example much better, it'll work. Okay, that's how prompting is very delicate. In your applications, you're probably going to have to try something and then iterate, and then keep iterating as fast as possible, because things like this will pop up quite frequently, and yeah. So the agent is there. It does exist. It is just not working. I'm
Is
going to
it
create.
in the file?
It is there. It is actually. It's that agent, tax or stock analysis agent, does exist.
Right.
So I think it's a parsing error, but I'm going to try something else now to fix that.
Mm.
So
And
let's
where
see.
does this registry get created?
This is in the JSON that the agent makes. So
Yeah. I have a feeling it's not reading the file enough, or it's buried in there or something.
Can we just check out what's in the JSON file just for
Yeah.
yeah, it's there for
a
sure.
dozen grins?
Okay, I think we might have fixed it. Let's just run it again and see if that'll work. So we're creating the boss right now, or creating the agents, and then we're going to, yeah, okay, so that's not working. Okay, so something else we could do to bypass this, so we could just pass in another swarm. I really wanted, I wanted you to see the rearrange because it's one of my
So
favorites, but I'm just going to do another one. Yep.
failing on the first agent of the communication flow, it looks like it's the first agent, and when it gets in the communication flow, it fails there.
Yeah, I have a suspicion it might just be the parsing. So it's like probably putting a white space or something, and then like, yeah, it's probably that. So in this demo, we won't need the flow. So we can comment that out and save ourselves lots of tokens. And then we also need to cut it out from every other thing. So just delete
The
that.
other thing I was wondering about is the examples that you had, whether you should put quotation marks around the individual agents
Yeah, that's actually a
so
good
they can.
idea. That's a good idea. You're right. Hmm. Well, hopefully this won't have any errors. This is a sequential workflow where we just have all the agents. I see. Let's see. Object name, agent before. I see. So plan the goal of the agent is of this form is to provide comprehensive analysis. Let me see something. So here, we don't need to do this. Um, I'm going to log that. Okay. Going to do another swarmy. Swarm, swarm, swarm. Okay. I'm going to specify the number of loops, and then save spreadsheet. Okay. Let's see. What else? What else? We're going to return, and that should be that. Let me just check one more thing. Make sure that this is going to work. Yeah, so that needs to be CSV, not a JSON. Okay. Now, so also add another parameter. Oh no, I already put. Okay, let's run this. Ah, yes. Oh, is that gonna work? Oh, I know why it's not working. I'm so dumb. The rearrange was working. Okay, I just forgot to give it the pool of agents. And would you look at that? It just ran. And now we have a CSV of all the agents outputs. So, okay, so basically what just happened is the boss created all the agents, and the boss created all the agents, and then we logged all of the outputs from each agent into into a CSV. So this is fucking amazing. Um, Let me just open up this thingamajigger here, which is a CSV, and then we can see the outputs. And would you look at that? That is that's the task. So actually, it's not that good because it's still getting all of this. So um, what we can do now is a couple of things. Um, so rules. So we can give it task. So now the JSON is going to contain another task, which we need to parse and send to this create agent. Actually, let's see if we can make this more pedantic. Pythonic, I mean. Okay. Um, so we're going to take that task, and then we're going to give that to the spreadsheet task for agents. Okay, so now we're going to run this again. So again, what's going to happen is first we're going to have the boss create the agents, and then after we have the boss create the agents, then we're going to log everything, and then after that we're going to create the agents, add them to the pool, which is just a list, and then after we do that, then we're going to run the swarm. So it's fully automated end to end. The only thing you have to do is say what you want the agents to do. And that's pretty much it. So again, the biggest problem with agents is parsing, prompting, getting the agent to output structured information to begin with. Those are like the biggest three problems. And it just finished. So the spreadsheet swarm is this one that we're making yesterday. Basically, the point is you can give a single task to many thousands of agents, and you can see all of their outputs in a CSV file. And until now, this was never done. So now you can just open up a CSV file and check the outputs of all the agents, which is a pretty simple and easy way to see all the outputs. So let's see if this is the CSV. Okay, so yeah, this is the newest one. We have a run ID for the agent. We have the name of the agent. And then we also have the task, which is provide financial advice on investing in stocks and bonds within a Roth IRA, include strategies for obtaining tax breaks. And so this is the this is what the agent, this agent, Roth IRA regulations agent said. And then income limit, The ability to contribute phases out between 138,000 and 153. Married filing jointly. The phase out range is between 218 and 228,000, et cetera, et cetera. So withdrawals. So this is probably the most important thing. To withdraw earnings tax free, you must meet two conditions. The account must be open for at least 5 years. Okay, so this is no taxes. Okay, you don't have to pay any taxes on the money that you make through your Roth IRA. And then you must be at least 59 years old, or the withdrawal must meet other qualifying conditions. First home purchase, disability, or death, fortunately. And so, yeah, that's an example of fully automated system. Here there's 11 agents. Yeah, risk assessment agent, tax optimization agent, bond investment strategies agent. So, yep.
I'm going to have to run shortly. Are you going to share this code back out onto the GitHub?
Of course. Yeah, actually, I'll just share it with you right now. The whole thing. I'll just
cool.
put everything
awesome
into the general chat. Yep, just put all the code there. So you, in the span of joining us, you have seen me start off with completely nothing except a model that can call structured outputs, and you've seen me literally build a completely hierarchical and a fully automated pipeline for creating agents. We've gone through one example. If you have any examples, now would be the time to let me know. I'm going to try marketing now. So we're going to create a swarm of agents that are specialized for every social media platform, and we're going to promote the swarms framework. So I'll show you how to do that. So basically here we have one point of entry. So here we're going to say create a swarm of agents that are they're specialized in every social media platform to market the Swarm's GitHub framework, which makes it easy for you to orchestrate and manage multiple agents in a swarm. Create 10 agents that are hyper-specialized in in different areas of social media marketing. Okay, so now we're going to say we need to promote the new spreadsheets swarm. Here is the link. Okay, so now we're just going to get some docs from our documentation, and then we're just going to pass it in the docs. So what else? What else? Okay, let's try it. So again, what's going to happen here is we're essentially going to be creating a bunch of agents for a bunch of different social medias, and then we're going to have all those agents just produce and market swarms for various social media platforms, 10 different social media platforms. And this would normally take a human maybe around a full day's work, probably even more than that. So here on the right, we have Quora. I've seen Reddit. I've seen tweets. Let's see. Let's see what we get. So it's actually funny because we just dropped the CSV, the spreadsheet swarm yesterday, and it was really slow. I mean, like really, really slow. And we optimized the hell out of it, and now it's finished in like 4 seconds. It's just utterly ridiculous. We just ran like 10 different agents in 4 seconds. And the goal, of swarms is to obviously get that number to go down as much as possible. So yeah, let's go check out our new CSVs and our new outputs, and we'll see what time is now. 6:25. Okay, so it was this one. Okay. So promote the new spreadsheet swarm feature on various social media platforms, ensuring widespread awareness and engagement. And so we have, how many agents do we have? We have one. It's not saying the number. Okay, there it is. We have 11. We have 11 agents. So look at that. We have agents for Quora. We have agents for Snapchat. We have agents for Reddit, Pinterest, YouTube, TikTok, LinkedIn, Instagram. I'm not even going to finish because that's a lot. Isn't this crazy? Okay, so let's start off with Twitter. Okay, so Twitter, we says, excited to introduce our game-changing feature, Spreadsheet Swarm. You can now you can run agents in parallel with ease. Transform your data management today. Check out docs.swarm.agent rearrange. And then we have a thread. Big news for all the data aficionados. Meet our hashtag spreadsheet swarm today, or meet our spreadsheet swarm feature. Now you can manage multiple agents seamlessly, boosting your productivity like never before. Imagine running complex calculations, data entry, and analysis in parallel to say goodbye to manual tasks. And I don't want to go too deep into that, so I'll just send you guys like all the CSVs so you can check them out yourself if you want, I guess. So now, what we can do to make this even more general is that we can take the swarm function, and we can add if, else, and when blocks, and we can get the boss to say, we want a sequential swarm, we want a parallel swarm, we want a spreadsheet swarm, and then we just parse that and then execute it. So yeah, does anybody have any questions, any demo ideas? I've been talking for a long time. I don't like talking, to be honest. I like coding and hearing people's desires and how agents can help them. So please let me know what you think.
Um, it's really cool.
Thanks, Patrick. Appreciate it. Um,
Do you have any new takes on resume writing or catering a resume to a specific job posting?
so, what's the use
Yeah,
case?
The use case would be that, you have a bunch of experience, and, it's kind of a balancing act, right? That you need to, resumes these days shouldn't be longer than, 2 pages, but when you have a lot of experience, it's tough to do it. But, then you get a job posting, and sort of the expectation is that that 2 pages worth of experience in the resume is focused on your broader sort of depth, focused into how that sort of helps you address the issues in the current posting, in the current job. So it's kind of like, yeah,
so
it's
so
not
one of the things
long,
I
but
was thinking would be is there's the job requirement and then there's the company, right? There's culture. These things are known. How do you take
that
your vast amount of experience and tailor
too,
it
yeah,
to
yeah,
address that
yeah,
specific need? And in a sense, what you're doing is, if you think about it, right, you have a swarm of people or a swarm of agents going, what is the need of the company based upon the company and the position? And then of all the stuff that you have available about your experience, how do you organize
exactly.
that into a resume that
Yeah,
matches that job description and what you know? In other words, you might have talked to somebody that says this is the other piece of information that's not necessarily in the job description. But
exactly. And in some
ideally,
cases, you almost need to rewrite the job description, um, to capture what's there, because sometimes these job descriptions are not helpful. So it's like, yeah. So I think a team would help, but, right now I've been using Claude 3.5 to do it, and it does a fair job. But
but in a sense, if you think about it, right, there's the HR screen you have to get through, and then there's for example, if you're doing coding, right, or PM or whatever it is that you're doing, you have to get technical enough to where when it gets in front of them, they go, okay, this is meaningful. And so, how do you write a resume that addresses the audiences? It's got to get through the gatekeepers.
exactly.
How could I formulate this? So you want to take a resume and then give that to the agents, and then have the agents update
Yeah.
a new one.
Yeah,
No, what
you're a young kid, so the aspect would be, think about it that, if you have a career that's spanned longer than 10 years, typically you've dealt with a number of, like as a developer, right? There's a number of industry use cases you've dealt with. There's a number of data, and application frameworks that you've dealt with, ML frameworks, and so, but you have to sort of filter that all down to, a specific, posting. And so it's not about lying or creating a resume that just
it's
would be their
tailoring.
perfect hire. It needs to take your experience and map it.
So what I was thinking, Kai, what you do is you take the job description and information about the company, right? So if it's a software developer for, Facebook versus software developer for GM, right? Um, so you take the job description and the company information, then you look at, let's say, for example, you might have a 9-page CV, right? It's got all sorts of stuff on there that he's done throughout his career. How do you merge that 9-page CV into um, relevant technical skills, life experiences, maybe even publications and so forth, relevant to the job description and what you know about the company? Is that a fair summary?
I like it.
Yeah. So okay, I need an existing summary, or I need some information at least. on a person
Okay.
before.
Do you have
There'd be
a
there'd be
span?
three inputs: the company, mission goals, all that kind of stuff, the job description, and then the user's CV.
Yeah.
Okay, say that
Do you
again.
have a swarm that can pull from LinkedIn? If you have something that can pull from LinkedIn, I can point you to my profile if you want an example.
Um, we can't currently do that. Like
No?
fetch. I mean, you can download a PDF and then give that to the agents. That's certainly possible. Um,
Mhm.
And
what are
then
the inputs,
suggestion.
Patrick?
Maybe this is a difficult example.
I, I, I think let me can I make a suggestion? The stuff that you're doing is creating the boss agent to find the team to do that is what's critical. Um, to me, being able to work with the different interfaces is kind of we can do that on our own. If I'm sorry to say, but the idea of what you're doing is creating these agentic teams. Um, if if you can keep enhancing that idea, I think that would be. I'm sorry to say that building an interface to LinkedIn or reading a PDF file is not that exciting to me right these days with AI. Um, Getting, for example, having it create a new team, an HR team to evaluate a resume, or uh, like you just did on the marketing. Maybe you can create a team to write the API interface. That would be impressive. Hey, we need
Yeah.
a team that generates the LinkedIn on the fly.
So I just tried one. So basically this I just tried another one and I said create a swarm of 10 agents that are specialized for sending API requests to OpenAI's API across major programming languages like Python, JavaScript, Go, Rust, and more. And the goal is to output the code for each of these languages to send API requests to OpenAI's API. And we have, how many agents is this? We have 11. So this is the Python agents, and it's basically creating the Python code to send an API request to OpenAI's API using the requests, and then this is the code. And then we have another agent that generates code snippets for an API request to OpenAI's API in JavaScript. Then we have another one in what is this, Go. Um, and so this could be like a way of like super fast multi-language app design where you can have a bunch of agents. You can have the boss created agents to build your whole app and then integrate the back end, front end, and Go and Rust or Python very easily, which would normally take a human probably months to do. Um, and so this is one example of that. Even Java, Jesus Christ, Java is so cancerous. Um, wow, what the hell? C sharp. What other language? We have Ruby. What the hell is Ruby? Uh, this kind of looks like Python. That's not bad. Um, PHP. Jesus Christ. Um, this is what is this?
Did you
PHP.
say you pushed the code into the chat already?
What was that? Did I
Did you
send this
push
one?
the code already?
Oh, it's a CSV file. But yeah, I'll send it now so you can see the code. So this is probably a good way to learn like a bunch of different like languages all at once. Um, we have a PHP API agents that generates PHP. Look at this. Damn, PHP is fucking weird. Um, what language is this? Swift. Okay, so Swift. Import foundation. Yada yada yada. That looks pretty simple. Nothing too crazy. Um, Kotlin. What the hell is Kotlin? Dude, some of these languages are ridiculous. Um, yeah. So that's warm. uh, let's see. What other ideas? Um, we can have we can generate games in Python. So we can say gonna make a new one here. So create a swarm of 10 agents that are specialized to create games in Python using various new various new game design patterns that are completely novel and unseen before. The agents should output the Python code for their game. And only their game. So this one is probably going to be trippy. I tried something like this before, and it was very, very weird. It was creating games that humans couldn't comprehend. It was creating like 7-dimensional games, games that are 5-person, second person. They're not 3D. They're not 1D. Just a bunch of weird shit. But it was fun. It was cool. So we just generated 10 games that have probably never been, or games with new game design styles that have never been seen before. Hopefully, let's see the results. Okay, so we're gonna grab a game and we're gonna just try running it. Let's see, game example. Okay, let's see. Okay, you are at the forest, a dark and dense forest. You see mushroom, exits cave village. What do you want to do? What the fuck? Um, wait, you see mushroom. Which item do you take? Mushroom? This is super weird, man. I don't know what the fuck this is. What do you want to do? I want to explore. Which exit do you take? Oh, shit. Cave. You are at the cave, a damp cave echoing with sounds. You see gem lantern, exits forest. What do you want to do? I see a gem. I want to explore. What the fuck are you talking about? Forest. Okay, so I'm at the forest, a dark and dense forest. I want to go to the village. Let's go to the village. Yeah, at the forest. Oh no, wrong command. Yeah, so that was super weird. Some of these generations can get very tricky. Augmented reality game. So let's see what the hell that one's about. Just gonna clean up that code. Let's see, man. Okay, so that one is gonna use a camera. That one didn't work. Let's try this agent. So we could probably have these agents generate oh shit, time manipulation game. What the fuck? I don't know what this one's about, man. Okay. All right. I'm gonna run the swarm again because I want it to be give them very very novel and weird game ideas to implement. They should have different names. Okay, we're gonna run it again. Are you ready? 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 Let's go. Let's go. Let's go. Let's go. Um. Oh, I think the game did work. It was asking me for my camera. I'm just gonna go ahead and send all this code to you, like the updated script, so you can run that. And yeah, let's see what we got. Let's see what we got. Okay, okay, okay. So what time is it? 4:44. Oh shit! Where's the CSV? Okay, gravity shift game. Okay, yo, this sounds crazy. Okay, guys, get ready, ready. Let's go. Let's go. Oh wow. So this game is like trying to get out of the gravity. The fuck, man. So I'm pressing the up down keys, but it's not like I can't go anywhere. Am I supposed to break out? I don't know, man. That one's a very weird one. Okay, so it's a color switch maze agent. Okay, that sounds. The code also looks pretty good. Let's try it out. Uh, oh wow, dude, what the fuck? Where's the out? Okay, so if you touch the blue ones, you die. I don't. It doesn't really tell you how to. I think. Okay, so the red are color switch. Let's try going green, maybe. Hmm. Yeah, that one's kind of weird. Soundwave surfer. Okay, this one looks really good. Is it the same one? Ride the sound waves. Oh, shit. It kind of looked like the last one. Shadow clone tactics. Let's see. Quantum leap. What the hell? Emotion control RPG agent. What the fuck? What do you guys think? All right, let's see if this one works. Emotion control. Oh, okay. Alice is feeling calm. Bob is feeling happy. Charlie's feeling sad. Choose an emotion to influence characters. What the fuck? I'm gonna say happy. You influence Alice to feel happy. Alice emotions change to feel happy. You influence Bob to feel happy. Charlie feels happy. Do you want to continue influencing? Dude, what the fuck is this game? Man, these agents are weird. Dimension shift. Light and shadow. Dream weaver. Alright, man. If you guys want to play some of these weird games, go ahead. Um, that was weird, man. That was super weird. We can make this like more and more better. Like if we use the sequential swarm, this could probably be much better for very specific tasks. But now we're essentially creating the spreadsheets. Um, in fact, I gotta get rid of all these spreadsheets because um, there's too many of them. Yeah, so that's that. That's been the how to design fully automated agents workshop. Um, we've gone over how to build, how do you build agents, how do you know get the boss to make a plan. We've seen some of the problems firsthand with some of these types of systems, mostly parsing, mostly getting structured outputs, and those are the two biggest problems really. Um, and then it's also actually the biggest problem is the prompt. The prompting is the biggest problem. And ideally, you should have agents build those prompts for other agents as much as possible because humans are just not good at them. So yeah, that's that. If you if you enjoyed this, if you enjoyed this, check out the Swarms framework, and we're going to be pushing a massive update pretty soon. So check that out, get started, and if you need help building any agentic systems, you can book a call with me, and through here, where is this? Yep, book a call with me for agents one-on-one. And yeah, that's that. Um, if you, I'm going to be posting the code as I'm going to be posting the full code in the examples folder in the Swarm repo. So if you want like the full updated code, that's where it'll be. I've also just gone ahead and sent it in the chat, anyways. So you have it there. And yeah, hope you had fun. And let me know if you have any questions here before I log off. We've been at it for almost 2 hours now.